All right, so this is our graphic organizer to help keep us organized for all our derivative rules. All right, so the first rule that we're going to do is the power rule. Which is going to be used for your exponents. So we're going to write d dx. What that means is instructions that are saying take a derivative. So that d dx means take a derivative. So we're going to take a derivative of x to the nth, something with a power. And so the rule is you bring the power down. So whatever that is, you're going to bring it down, put it out front, and then you lower the degree by 1. And we talked about that whenever we were graphing the derivatives. Remember, we had a cubic graph and the derivative ended up being a parabola. A parabola would be linear, linear would be constant, constant would be 0. It's always going to go down a degree is what that's saying. So let's do a few of the examples from the paper using the power rule. So like I'll tell you one of the rules and then we'll do a few examples and then, but it just froze. All right, so for number 1, we're going to write f prime of x. And you're going to do each term separately. So for the first one, you're going to bring the power down. That would be 12, and then subtract 1 from the exponent. So it would be to the third. And then minus, what's the next part going to be? Yeah, 12x to the first. And then 1 is a constant, so that's just going to go to 0. So that's like literally it. Okay. Square root of x. That is really x to what power? Because if you're going to do the power rule, it would help a lot if you had a power. So when you go to do the derivative, you're going to bring the power down. That 1/2 is going to be out front. And then you subtract 1. So a half minus 1 would give you what? Negative 1/2. Good. So the 1/2 power means square root. The fact that it's negative means it goes down to the denominator. So this is going to be 1/2 square root. That 2 is in the denominator. And then this goes down to the denominator as well because of the negative exponent. Here's what I always tell everybody. Just know that one. Square root shows up a lot. And if you just know it's 1/2 square root, you are so much better off than having to deal with that as the negative 1/2 every time. Are you understanding what I'm saying? Yeah, just know that one, okay? 1/2 square root. All right, this one. 3 over x to the 5th. That would really be 3x to the negative 5th. And then we're going to do the power rule for that. So you would multiply the power down. That would be negative 15. And then this is a little tricky. You subtract 1. So it's going to be good, negative 6. You make it more negative. And then you have to fix the negative exponent. Because you can't leave it like that. So that would be what? If I fix the negative exponent. Yeah, perfect. Negative 15 over x to the 6th. Honestly, power rule, the hardest thing is dealing with the fraction and negative exponents. All right, and then if you have something like f of x equals 16/23, well, there's no variable with that, so it's constant. So that derivative would be what? Yeah, just 0. So if you have just a number that's constant, that derivative is going to be 0. All right, let's do the next rule. So next rule is product rule. So product means that you're doing what? Good. Multiplying. So you have one function times another. So d dx, again, that's instructions that mean take a derivative of f of x times g of x. You're multiplying them together. Don't get hung up on them being called f and g, okay? Because what if it was g and then f? Or what if they were H and Q? You know, in your brain, think of them as the first thing and the second thing, because they can be called whatever, and you don't want to get stuck on that. All right, so product rule is the first function times derivative of the second plus the second function times derivative of the first. And if you want to do that in the other order, that's okay, because it doesn't matter what order you add in. I'm going to always do it this way just for consistency's sake. Plus, I just like starting with the first function. But again, you could do this the other way around. All right, so let's try a few examples on that. The biggest battle with all these derivative rules is knowing when you need which rule. The way I know I need product rule here is I have 2 separate functions or items, if you will, in the parentheses. So this parenthesis, this is the first function, And then this is the second function, and watch out because there's a negative exponent there. All right, so our derivative is going to be the first thing, which is this x cubed plus 7x minus 1, times derivative of the second. So with that x to the -2, you would bring the -2 down and then subtract 1. Just be careful because it makes it more negative. And then derivative of 5x would just be 5. So that's first times derivative of the second plus the second function. So just copy that down. Times derivative of the first. And so it's not just me blathering on up here. What is the derivative of that first item going to be? Perfect. Now the rule of thumb is you can leave your answer how the question was written. So since this question had negative exponents, we can leave our answer with negative exponents. But just for the sake of being thorough, I'm going to go ahead and fix them anyway. This would be -2 over x cubed. And then this one would be 1 over x squared. But that is the rule of thumb. However the question was written is how you can leave your answer. But I want you to understand negative exponents, so I just went ahead and fixed it. All right, why don't you guys try this one? I'm going to pause the recording real quick. Try number 6, and then I'll give you the answer. Okay, so for this one, we're going to have the first function times derivative of the second, that would be 2x minus 3, plus the second function times derivative of the first, that would be 14x to the 6th. You could distribute all that together, but like, what would be the point? You know, just leave it alone. All right, so this one, we're going to do the same thing. This fourth root of x is x to the 1/4. So maybe just like write that right above there. It's x to the 1/4. Because if you're going to do the power rule, you need it written with a power. Again, the hardest thing about power rule, honestly, is dealing with the fraction and negative exponent. All right, so product rule, because I have two separate things going on here. It's the first function, just copy that down, times derivative of the second. All right, so the 1/4 comes down, and then you have to subtract 1. So a fourth minus 1. Good, -3/4, which I know that looks scary. We'll fix it in the next step, right? Plus the second function times derivative of the first, that would be 3x squared plus 2. I usually just erase it and fix that one part. You can do that if you want. Your notes are yours. You can do as much or as little as you want. I'm going to rewrite the whole thing though, just so when I take a picture of this and post it, it's all on there. This x needs to go back down to the denominator because of the negative exponent. And that 4 is in the denominator for the 1/4. This would be a fourth root of x cubed. And you can also write it fourth root of x and then the cubes. That means the same thing. It doesn't matter. And then the rest of this is all just going to stay the same. And I always get asked, like, how do you know which type of root it is? Well, there's two ways. First, the denominator tells you what type of root, but also it's going to be the same type of root it was in the problem. If the problem had a fourth root, the answer is going to have a fourth root. It can't like magically change into something else. So it'll be a fourth root. All right, we're going to need to look at the next rule. Are these coming back to you? Were you going to add something in there? Oh, you just looked like you're going to say something. All right, so that was product rule. What's the next one? Quotient rule. So a product means you're multiplying, quotient means you're dividing. Now, when I said for product rule, you can do that one in the opposite order because for adding, it doesn't matter. This one has subtraction in it, so you cannot do it in the opposite order. You have to do it in the order that I show you. So it's d dx of a fraction. And I'm going to say again, don't get caught up on f and g. Call them in your mind the numerator and the denominator. Because they might not be called f and g, or g might be the numerator and f might be the denominator. So, you know, and I don't want that to throw you off. All right, so it is the denominator times the derivative of the numerator minus numerator times derivative of the denominator all over the denominator squared. What I get a lot is people are like, I don't remember where to start. Start with the denominator. If you remember where it starts, you will probably get the rest of it. Or like if you just want to remember these two things match, but they do not cancel out, don't cancel them, but like these are going to match. It's going to start with the denominator. All right, so let's try a few of these. Kind of like this unit. It's very cut and dry though. It's a little boring, but if you know the rules, then you're going to be okay, sort of. Yeah, like they're almost just like puzzles you have to figure out. It's not super interesting. But then what I always tell people is, well, interesting means word problems. And they're like, no, okay, we'll do this. All right, so denominator, so 2x minus 1, times derivative of the numerator, which is just 3. That 7 is going to go away because that's constant. Minus the numerator times derivative of the denominator, which would just be 2, and then over the denominator squared. The most common mistake we always see here is that people will cancel these out. Don't do that. You guys with me when in pre-calc, no cancellation without factorization. Do you guys remember that? So if you did not factor, you cannot cancel. All right, instead what we're going to do is we're going to distribute this 3, and I'm just going to write right above here. If you distribute that 3, you're going to have 6x minus 3. And through here, we are going to distribute the 2, but we're also going to distribute the negative because you want to subtract both of those terms. So think of it as distributing a negative 2 through there. That would be negative 6x minus 14. And so what's going to happen there? Yeah, 6x's cancel. You have negative 3 and negative 14, so it'll be negative 17 over that denominator. This one we're not going to distribute and simplify down. Again, I'm going to pause the recording. I want you guys to try number 9, and then I'll do it. All right, let's see how this one went. Yeah, I wouldn't. Yeah, just stop. This one turned out okay because the derivatives were just a 3 and a 2, so it was all right. This one's going to be, was it obnoxious? Yeah. Obnoxious, yes. All right, so denominator, derivative of the numerator, that would be 2x minus 3 minus the numerator times derivative of the denominator. That would be 15x squared minus 1. Did you guys get the minus 1 there? Because that's always a little tricky. Like if it's just 1x, then it's minus 1. And then over the denominator squared. And yeah, I would stop there. There's not really much you can do to make that nicer. I mean, if you distribute all this to each other, but I would just leave it alone. All right, so let's try this one. So it will be the denominator times derivative of the numerator, which would just be 1. I'm going to write it for the sake of keeping the pattern in there. If you don't want to write the 1, you don't have to. If I don't write it, I'm going to forget that I did it. All right, minus the numerator times derivative of the denominator. All right, you can look back if you want to, but we should just know derivative of square root. You need to just have that one in your back pocket. And it's in the denominator, so 1 over 2 square root. And then over denominator squared, what's that going to be? X. Now I am going to fix this up because we have a fraction inside of a fraction. I'm going to multiply the numerator and the denominator by 2 square root of x to get that to cancel out. And so I'm going to distribute that through here. Because this one, we actually can make it look a little bit nicer. So if you distribute that, for the first term, you're going to have 2 square root of x times square root of x. That would just be 2x. And then for this second term, these are going to cancel out, which is the whole idea. So it's minus x plus 5, so it'd be minus x minus 5. And then the denominator would just be this, 2x square root of x. And then the last step there, 2x minus 1x would just be x. And I feel like it is worth it in that case. Like this would not be worth it. That's just a gigantic mess. Here, it is worth it to fix that fraction because this does look nicer. So I think it is worth it. All right, I'm throwing vocabulary at you now. You'll see these last three on this page have like words in them. Find the instantaneous rate of change. But what does that mean? Yeah, derivative slope of a tangent line of this. All right, let me rewrite that equation real quick. It's 2 over cube root of x. So that would be 2x to the what power? Good, negative 1/3. Negative because it's in the denominator, a third because it's a cube root. All right, so we're going to do the derivative. Bring the negative a third down. That would be negative 2/3. And then really tricky, you have to subtract 1. So it's going to be more negative. Good, negative 4/3. Negative 1 and a third. So negative 4/3. And then I'm going to clean that up a little bit. It's going to go back down to the denominator. And it would be a cube root of x to the 4th. And you can put the 4th inside of there, or you can do cube root of x to the 4th. It doesn't make a difference, but it'll be cube root of x to the 4th. All right, and then I think I was plugging something in. All right, we're going to plug in 8. Oh, that's a 3. I'm sorry. There, is that better? Did I mess something up? Oh, this 2 right here isn't part of the exponent on the x. It's no, I understand what you're asking now. No, that 2 is like coefficient to the whole thing. So they're all really tiny, so it like is totally like that just happened. Look at Jenna's like, I know you need like a microscope. See, if I make the font bigger though, how many pages would this packet be? You know what I mean? So we will just get through it together. All right, plugging in 8. What is your cube root of 8? That's 2. Do we know what 2 to the 4th is, or can we count it out on our fingers? 2 times 2 times 2 times 2. Good, that'll be 16. Here, let me write it out. So we're here. 16 times 3, 48. And then that's going to reduce to negative 1/24. All right, I do want to show you how to do this on the calculator. So I'm going to pause the recording and let you all grab a calculator. So your calculator will not do a derivative, but it will do a derivative at a specific value. And they throw you at least one of these on the AP exam, where literally all you have to do is put in the calculator. It's in the math menu, so please go to math, and it is math 8. If you forget that it's number 8, it says derive. So we're all going to choose math 8. And it's ddx, so hit your variable key for x. In those parentheses, you're going to put the function, and then that bar is such that, this means such that, and then you would put x equals whatever value it is you want to plug in. So for this one we just did, for the function, you're going to put in 2 over cube root of x, and then for such that, you're going to put 8. If you hit alpha y equals and hit n over d, it's the first choice, it'll give you the fraction bar. And then the cube root is also in the math menu. Yeah, and now see, here's the thing though, we got negative 1/24, which if you type in negative 1/24, it is that, but negative 1/24 is actually a more perfect answer. Like it's gonna get it close, but anyway. Okay, will it do that? Sometimes it will and sometimes it won't. It did, yeah, sometimes it does and sometimes it doesn't. But anyway, math 8, it will do a derivative at a specific value. And I know like, it's like one more thing to remember, but they will throw you one of those and you can just get the answer. So it's nice. All right, we'll do these 2 and then I'll give you a brain break. All right, write the equation. What 2 things do you need to write an equation? Point and a slope. All right, our point is going to be negative 1 something. Then we'll get our slope. I just always write that out and leave it blank. I'm like, oh, okay, I'm going to fill it in. So we're going to take negative 1 and plug it in to get our y value. If you plug in negative 1, that's going to be negative 6 over 4, so negative 3/2. Slope comes from derivative. So you have to find the derivative. All right, what rule do we need for this one? Good, perfect. It is going to be denominator times derivative of the numerator, which is just 6, minus the numerator times derivative of the denominator, which weirdly is also 6x, and then over the denominator squared. What I get that happens a lot here is people will try to distribute that and combine all the like terms and simplify it down. Don't do that. It is a lot easier to deal with numbers than variables. All you need to do is plug in -1. So just plug in -1 and see what you get. All right, if you plug in -1, what's this first part? 4 times 6 will be 24 minus. All right, now if both of those are -1, the negatives are going to cancel. Just have 6 times 6 will be 36. And then down here, that'll be 4 squared, which is 16. So let's see, what is that? -12/16. So -3/4. And so that is your slope. So don't try to mess with all of the algebra. Just plug in whatever number it is you're wanting to plug in. And then don't forget to write the answer. This is your point. This is your slope. You have to put it all together. It'll be y plus 3/2 equals -3/4 x plus 1. That is your final answer. We were asked to write the equation. Yeah, these next ones are nice, and I'll throw you one on the test. All right, find the fourth derivative of this. All right, well, let's see what you guys have got. What's the first derivative? Plus 4x, good. And then the second derivative, these are called higher order derivatives. It just means do it again. So the derivative of the first derivative, that would be 36x plus 4. Now, when you go above that, you can just put a little 3 there. That's the third derivative, which would just be 36. If you have a polynomial, it's going to cycle down. And then derivative of 36 is 0. 36 is a constant, so it's just going to be 0.